problem, we'll have area bounded by the curves in RCS or in rectangular coordinate system. So we have the differential dA is a rectangular strip which is either horizontal or vertical in position depending on the continuity of limits over the region. So for you to appreciate it more, we have an example here. So for number 1, we'll have find the area region bounded by the curve y equal to x cubed, y equal to 8, and then x equal to 0. Okay, so already drew the graph of that. So this is the red one. Okay, the red line is actually the one that represents the graph y equal to x cubed, and then the blue one, of course, will be the blue one will represent the line y equal to 8, and of course x equal to 0 will be just the y-axis. So this is the so the intersection of those three graphs will be the region that we will be looking, hence this one. Okay, so this region. And then as you can see from the definition, you have to get here the rectangular strip. Okay, so getting a rectangular strip here, let's try to get a rectangular strip here, that one. If that is a rectangular strip, as you can see, this element here will be your dx, no, dy, and then this will be your x. So you can see if that is a so this, okay, this length will be your dy, and then this length will be your x. Okay, so if that is a rectangle, therefore the area of that is just the x dy, right? So dA is just equal to x dy. So taking the integral of both sides, you'll have your a equal to the integral of x dy. But since we are doing area, so this must have a limit, and then you have to express x in terms of dy. So that's really easy because we have the equation of y equal to x cubed. Okay, and then we have taking the raise both sides by 1/3, therefore you will have here y raised to 1/3 equal to x. Therefore we have to replace the x on the equation with y raised to 1/3. A equal to integral of y raised to 1/3. And then of course we must have limits. So the limit of this one is, as you can see, we started from here, which is the coordinate of that is 0, 0, and then we ended here. Okay, we're just looking at the y coordinates, and then the coordinate of that, as you can see, this is 8, right? Therefore the coordinate of that is 0 and 8. Therefore our limits must be 0 to 8. 0 to 8. And with that, you can just use your calculator to solve this for this one. And you can also use just power rule. This really is, and then substitute the limits. So the answer here will be 12 square units. Let's move on to the next one. Okay, so we have here number 2. So this is actually a shortcut, or not a shortcut, but an easy way to solve area bounded using integral calculus without graphing. Okay, without graphing. So what happens here, if you want to get the area here, okay, so we have here, find the area of the region bounded by the curve y equal to x cubed minus 4x squared plus 3x, and y equal to 0 from 0 to 3. Okay, so as you can see, we have a limits here. The limit is already given as 0 and 3. Therefore, if your limits here is 0 and 3, and that is with respect to x, you must have here dx. Okay, dx. Okay, and then of course what you must write here is a term containing x only. You don't have you must have here a term containing x only. You know, it must have free of y. Like it doesn't have y mass. And then what happens here is, as you can see, this is already in terms of x. So y is equal to x cubed minus 4x squared plus 3x. And then write it down. So x cubed minus 4x squared plus 3x. And then the trick here is you have to write, add here the absolute value. Okay, as you can see, absolute value is a really strong operator. Okay, so if you will just put it in your calcu, and you will able to solve this problem without graphing, even though if you don't know what kind of graph, x cubed by 4x squared plus 3x, this is really useful. You can even use this on the first problem. Okay, so the answer for that is just 3.08 square units. Okay, just don't forget the absolute value. Okay, so we have here number 3. So find the area under one arc of a cycloid. So we have given x equal to a times theta minus sine theta, and then y equal to a1 minus cosine theta. Here's a note that a cycloid is a locus of fixed point on a circle with radius a. So the radius is a that rolls on the horizontal. So that is quite hard to understand, but this is what it looks like. So as you can see, we have here the x and y axis, okay? And then this is actually the cycloid, okay? This one. Let me just change the color of the font. So as you can see, what happens here is, if this circle, okay, you can see this circle rolls, okay, it rolls, that is, and then this dot will just remain on the circumference of the circle. You will eventually get this arc. Okay, so that's actually the one that will be generated by that point is actually a cycloid. So this is the cycloid, and then we are asked to find one not the one arc, okay, the area of one arc. So that is one arc. Okay, so let's get again a rectangular strip. Okay, so let's just get a vertical strip. Okay, so vertical strip. So if that is a vertical strip, therefore this one will be your dx. Okay, so that is dx, and then this is your one. So to get the area of that, that is just the integral of y dx. Okay, y dx. But we already have a call this one. Value of x is equal to a times theta minus sine theta, and then for y, a times 1 minus cosine theta. Okay, and then we already have the value for y, and but we don't have the value for dx. Therefore, getting the dx, so you have, all you have to do is just derivative x. So derivative of that, of course, you can just, a is a constant, right? That is the radius. So derivative of theta is just 1 minus derivative of sine theta is cosine theta. Okay, so this will be your dx. Okay, and then let's try to, I forgot here d theta. You must have a d theta there. Okay, so let's substitute the values. So y is a1 minus cosine theta. Okay, so that is your y, and then dx is a times 1 minus cosine theta. Okay, so don't forget the d theta. Okay. And then area, as you can see, we have two a's. So I can just bring out those a's because that is just a constant. And then we have here 1 minus cosine theta and 1 minus cosine theta. Therefore, we'll just have here 1 minus um, cosine theta squared. Okay? And of course, we must have here a limit. So the question is, what is the limit? Of course, if the arc starts here, okay, the arc started from here, so that will become your 0, and then it ends here. And it was able to complete one cycle. Therefore, that is 2 pi. Okay, so that is 2 pi. So if you were able to complete one cycle, therefore your limits here must be 0 to 2 pi. So I think that's it. So all you have to do is just um, input this in your calcu again. So just to make it easier. So the answer here will be this part will be 3 pi. So don't forget the a squared. Therefore, the answer is just 3 pi a squared. So this will be the area of a cycloid of one arc. Okay? So let's move on to the next one.